after the fire goes out. By the time this chapter opens, something has already happened. That's the strange part. There's no beginning here to point to. A room cools after the last person leaves it, and nobody was watching the exact moment the warmth gave up. You've felt this. You come back into a kitchen an hour after everyone's gone home, and the air has a different weight to it, a stillness that wasn't there when the room was full. Nothing dramatic occurred. The heat simply left, quietly and in every direction at once, the way water finds the low points in a floor without needing to be told which way is down. Here's the part that goes down strange, though, and it's worth letting it be strange rather than smoothing it over. This isn't a special property of coffee or kitchens or planets. It is, as far as anyone has been able to find, the only rule in physics that seems to care which way time is pointing. Almost every other law works the same, played backward as forward. You could watch a video of two billiard balls colliding and, run in reverse, it would look like perfectly normal physics. But show someone a video of a shattered coffee cup reassembling itself off the floor, and they will know instantly, without doing any math, that the footage is running backward. That single reaction, that flash of wait, no, is you personally detecting the arrow of time with nothing but your gut. Nobody built that arrow. It isn't stamped into the fabric of the universe as a rule the way gravity is a rule. It appears to be a consequence of arithmetic, of there being so many more ways for a system to be disordered than ordered that disorder simply keeps winning the count. That's an odd thing to build a universe's forward motion out of. Not force, not decree. Probability stacking itself over and over until it starts to look, from the inside, indistinguishable from a law. Sit with that for a second, because it's doing more work than it looks like it's doing. Nothing in this description involves force, or intention, or even physics in the way you were taught to picture it. No invisible hand pushing heat out of the coffee cup. It's closer to a coin that's been flipped an astronomical number of times. Heads and tails aren't fighting each other. There's just, overwhelmingly, more ways to land on spread evenly across the table than stacked in one corner. Given enough flips, spread wins. Doesn't have a choice, and neither does the coffee. Sit with that for a second, because it's doing more work than it looks like it's doing. Nothing in this description involves force, or intention, or even physics in the way you were taught to picture it. No invisible hand pushing heat out of the coffee cup. It's closer to a coin that's been flipped an astronomical number of times. Heads and tails aren't fighting each other. There's just, overwhelmingly, more ways to land on spread evenly across the table than stacked in one corner. Given enough flips, spread wins. Doesn't have a choice, and neither does the coffee. Somebody, somewhere tonight, is going to hear that and immediately need to say it out loud to another person. Not because it's frightening, because it's the kind of fact that doesn't fit in your hands quietly. You'll notice the shape of it later, probably tomorrow, in the middle of something unrelated doing dishes or driving. The way you notice a splinter only once you've stopped moving. There is a number, and once you hear it, you will not be able to put it back down. Every second, somewhere close to 10,000 trillion protons inside your own body are, in a purely technical sense, betting on their own survival. And the current best guess from physics is that every single one of them will eventually lose. Not soon. Not in a way that touches your life, or your children's lives, or the life of anything that will ever be called a species. But the bet is real, and it is running right now inside you while you lie here. There's a word for what's happening in that kitchen, in your hands, in the cooling coffee you forgot about 20 minutes ago. Physicists call it entropy, though the word itself is almost beside the point. What matters is the direction it points in, and the direction never changes. Heat moves from where there's a lot of it to where there's less of it. Always. Not because heat wants anything. Wanting isn't really available to it. But because there are simply more ways for warmth to be spread out than there are ways for it to stay clenched in one place. A universe with 2 billion possible arrangements of spread out and one arrangement of concentrated here is eventually going to land on spread out. Not through effort, through odds. This is not a story about beginnings. Almost everything you'll ever be told about the universe wants to start at the start. The first spark, the first light, the moment the clock reads 0. That's a fine story. It's just not this one. This one starts here, in the residue, in the space after. We're not going to explain that number yet. It isn't ready to be explained. Some things have to sit in a room for a while before they mean anything. Your hands are cold right now, or they will be soon, and you won't remember the exact moment that started either. I'll be honest, that part still catches on something for me every time I sit with it. Not because it's wrong, because it means the thing we call the passage of time might not be a river so much as a very, very long losing streak. It's easier if you don't think about the universe yet. Start smaller. A cup of coffee left on a counter does not get hotter on its own. A block of ice does not spontaneously refreeze itself into a tighter shape after it's melted into a puddle on the floor. A rubber band left too long in a drawer loses its stretch and does not, no matter how much time passes, wind itself back into a tighter coil. These aren't punishments. Nothing chose this for the rubber band. It's simply that the number of ways a rubber band's molecules can arrange themselves into loose and tired vastly, vastly outnumbers the ways they can arrange into taut and new. Given enough time bumping around at room temperature, the tired arrangement is where almost everything ends up, because almost everything is tired arrangement. Multiply that logic by every object in a room, then every room in a building, then every building on a planet, then every planet around every star. The direction doesn't reverse at any of those scales. It just keeps going, patiently, the same way in every single case, because the math underneath it doesn't know the difference between a kitchen and a galaxy. It only knows counting. This is where the number from the beginning of the chapter starts to make a little more sense, though not all the way. Not yet. If disorder wins over order at the scale of coffee and rubber bands and cooling kitchens, then the same betting odds apply to absolutely everything smaller than that too, down past cells, past molecules, past atoms, all the way down to a proton, which most of us were taught to think of as one of the permanent, unbreakable bricks the universe is built from. Permanent is a word we use because our lives are short enough that some things never seem to change within them. It isn't a word physics is required to agree with. We're not going to finish that thought tonight. It doesn't want to be finished yet. Some ideas need a few more rooms built around them before they're ready to be looked at directly, and this is one of them. For now, it's enough to notice that the coldness in your hands, the quiet kitchen, the untouched coffee, and something as vast as the eventual fate of matter itself are underneath all of it, obeying the exact same small rule. Not a punishment, not a warning, just counting, running the same direction it has always run, in every room you have ever stood in and every room you never will. Your hands are cold. You still don't know when that started. Maybe that's the wrong question to be asking about any of this. The weight of almost nothing. Nothing here is dramatic. To look for drama in the corner of a room is to misunderstand the nature of the room, and perhaps to misunderstand the nature of looking. A glass of water sits on a table. It is a standard glass, cylindrical, made of silica that was once sand, melted and cooled into a rigid, amorphous solid. Inside it, water. The water is not moving, or rather, it is moving so completely, so violently at the microscopic level, that to the naked eye it appears perfectly still. Millions of trillions of water molecules, H2O, jostling and vibrating, forming and breaking hydrogen bonds with a frantic, invisible desperation. They bump against the inner walls of the glass. Some of them, those near the surface, possess just enough kinetic energy to break free of the liquid's cohesive pull. They escape into the air. This is evaporation. It is happening right now in this room, at a rate too slow to see but too constant to ignore. The water level drops by a fraction of a millimeter over the course of an hour. It is a loss so small it cannot be measured by the human eye, yet it is a loss nonetheless. The glass is slowly emptying itself into the atmosphere, giving up its contents molecule by molecule, surrendering to the ambient humidity of the room. This is not a metaphor for grief, or for the passing of youth, or for the slow erosion of a relationship. It is simply water leaving a glass. It is the thing itself, small and persistent, doing what it was always going to do whether anyone watched or not. The universe does not require an audience to proceed with its business. The water does not know it is in a glass, and the glass does not know it is holding water. They are merely occupying the same space, bound by temporary physical laws, waiting for the conditions to change. On the table, a few inches from the glass, there is a breath exhaled into winter air, or rather, the memory of a breath, the physical residue of one. When warm, moist air from the lungs meets the cold, dry air of a winter room, the water vapour condenses. For a fraction of a second there is a cloud, a tiny localized weather system born of biology and thermodynamics. It hangs in the air, a ghostly plume of microscopic droplets. Then the droplets evaporate. The cold air absorbs the moisture, the temperature equalizes, and the cloud vanishes. It is there, and then it is not. The air is slightly more humid than it was a moment before. The heat from the breath has dispersed, radiating outward, warming the surrounding air molecules by an imperceptible fraction of a degree. The energy is conserved, but it is lost to the specific, concentrated form it once held. It is now just background noise. The breath has joined the room. In the drawer of the table, a rubber band has been left too long. It is looped around a stack of old receipts, or perhaps it is just lying there, twisted upon itself. Rubber is a polymer, long chains of molecules tangled together like a bowl of cold spaghetti. When the band was new, the chains were flexible, able to stretch and snap back, storing and releasing elastic potential energy. But time, and the ambient oxygen in the drawer, and the slight fluctuations in temperature have been at work. The polymer chains are slowly breaking. The cross-links that give the rubber its elasticity are degrading. The band is losing its tension. If you were to pull it now, it would not snap back with the same vigor. It would stretch, slowly, and then remain stretched, or it would simply snap, brittle and dry. It is undergoing a chemical change, a slow oxidation that turns the flexible material into a rigid, lifeless husk. It is forgetting how to be a rubber band. It is becoming something else, something without a name, a degraded state of matter that no longer serves a purpose. These are not metaphors for anything larger. They are the physical reality of the world. The weight of almost nothing is the cumulative effect of these tiny, imperceptible shifts. It is the dust settling on the surface of the glass. It is the slight yellowing of the paper receipts in the drawer. It is the way the light from the window shifts across the table over the course of the afternoon, marking the rotation of the earth, a movement so vast and so smooth that we feel entirely stationary. We are built to notice the dramatic. We are built to notice the glass shattering, the breath gasping in shock, the rubber band snapping against the skin. Our nervous systems are evolved to detect sudden changes, sharp contrasts, loud noises, rapid movements. We are blind to the slow, the quiet, the almost nothing. But the almost nothing is where the actual work of the universe is done. The dramatic events are just the brief, loud interruptions in the long, quiet process of things wearing down, shifting and settling. The glass of water, the breath in the air, the rubber band in the drawer, they are all participating in the same grand, silent project. They are all moving toward equilibrium. They are all losing their specific, concentrated forms and spreading out into the general, undifferentiated background of the world. There is a profound comfort in this, if you can learn to see it without projecting your own anxieties onto it. The water evaporating is not dying, it is joining the atmosphere. The breath dispersing is not vanishing, it is becoming the room. The rubber band degrading is not failing, it is returning to a simpler, more stable chemical state. The weight of almost nothing is not a burden. It is simply the mass of the universe, going about its business, indifferent to our need for meaning, steady and relentless and entirely complete in itself. You can sit and watch the glass of water for an hour, and you will see nothing happen. But if you watch it for a year, the glass will be empty. If you watch it for 1,000,000 years, the glass itself will have degraded into sand. The almost nothing adds up. The quiet accumulation of tiny changes is the only true engine of time. What the cup cannot undo. Can a shattered cup reassemble itself if you wait long enough? The question feels like a riddle or a trick of philosophy, but it is actually a question about the fundamental nature of reality. We are taught that time is a river flowing in one direction. We are taught that cause precedes effect, that the breaking of the cup is the result of it being knocked off the table, and that the shards on the floor are the permanent consequence of that action. But at the level of fundamental physics, the equations do not care about the direction of time. If you were to film a single atom bouncing off another atom and then play the film backward, the reversed footage would look perfectly normal. The laws of motion are symmetric. They work just as well forward as they do backward. So why can't the cup reassemble itself? If the laws of physics allow for the reverse process, why doesn't it happen? The honest answer takes the whole chapter to arrive at, and even then it arrives sideways. It has to do with probability, and the sheer, overwhelming vastness of the ways things can be broken compared to the single, specific way they can be whole. When the cup falls, it hits the floor. The kinetic energy of the fall is transferred into the ceramic. The molecular bonds which held the silica and clay together in a rigid, ordered lattice are subjected to a stress they cannot withstand. The bonds break. The energy of the break propagates outward as sound waves, vibrating the floor, vibrating the air, vibrating the soles of your shoes. The cup shatters into dozens, perhaps hundreds of pieces. Each piece has a specific shape, a specific trajectory, a specific resting place on the floor. For the cup to reassemble itself, every single one of those pieces would have to move in exactly the reverse of the trajectory they took when they fell. The sound waves in the air would have to converge perfectly on the shards, pushing them upward. The vibrations in the floor would have to channel their energy back into the ceramic, guiding the pieces together. The molecular bonds would have to reform perfectly in the exact same configuration they held before the break. The probability of this happening by random chance is not just small, it is so infinitesimally small that it is effectively zero. It is a number with so many zeros after the decimal point that you could write them until the end of your life and never finish. Pieces don't remember where they came from. A shard of ceramic on the floor does not contain the memory of the handle it was once attached to. It does not know its place in the whole. It is just a piece of baked clay, subject to gravity and friction. If you were to sweep the pieces into a dustpan and pour them back into the mould of the cup, they would not fuse. The bonds are broken. The history of the cup is written in the broken edges, in the microscopic fractures that radiate from the point of impact. Time, it turns out, has a direction the way a hallway has a direction. You can walk back down it, but you cannot make it lead somewhere new. The hallway of time is narrow and strictly one way. You can look back down the hallway and see the cup whole on the table. You can remember it. You can hold the memory of the whole cup in your mind, perfect and unbroken. But memory is a trick of biology, a way for a brain to store information about the past to help it navigate the future. The memory of the cup does not exert any physical force on the shards on the floor. The past is gone, locked behind the door of probability, and the key has been thrown away. This is the second law of thermodynamics, stripped of its mathematical formalism and reduced to its emotional core. Entropy always increases. Things break, they mix, they cool down, they wear out. The universe is moving from a state of low entropy, high order, like a whole cup on a table, to a state of high entropy, high disorder, like shards of cup on a floor. This is not a moral judgment. The universe is not punishing the cup for being fragile. It is simply a statistical inevitability. There are vastly more ways for a cup to be broken than for it to be whole. Therefore, if you leave the universe to its own devices, it will eventually find one of those broken states. We spend our lives fighting this. We glue the cup back together, we use epoxy, filling the gaps with a synthetic resin, trying to force the pieces into a semblance of their former unity. The mended cup holds water again mostly, but it is not the same. The cracks are visible, a map of its trauma. It is weaker now. The glue is a compromise, an admission that the original state cannot be restored. We do this with everything. We repair our bodies with medicine. We patch our relationships with apologies. We restore our buildings with scaffolding and new bricks. We are constantly pushing back against the tide of entropy, spending energy to create local pockets of order. But it is a losing battle. The energy we spend to fix the cup generates heat, which dissipates into the room, increasing the overall entropy of the universe. We are only delaying the inevitable, and in our delay, we are accelerating the larger process. The cup cannot undo its shattering. This is the hard, unyielding truth of the physical world. Once a thing is broken, the specific arrangement of atoms that made it whole is lost to the vast, chaotic ocean of possibility. You can build a new cup from new clay, fired in a new kiln. It can look identical, it can serve the same function, but it is not the same cup. The history of the first cup, the specific sequence of events that led to its creation and its destruction, is unique and unrepeatable. The shards on the floor are a monument to that history. They are the physical record of a moment in time that can never be undone. To accept this is to accept the fundamental nature of existence. We are all, in our own way, cups on a table, waiting for the edge, knowing that once we fall we cannot be put back together. We can only be swept up and remembered, and perhaps for a little while, held together by the glue of our own making. Long after the light leaves, stars burn for a length of time that makes a human life look like a held breath. We measure our existence in decades, perhaps a century if we are lucky and the biology holds. We measure the history of our species in millennia, a mere blink in the cosmic eye. But the stars operate on a timescale that breaks the human mind. A star like our sun will burn for 10 billion years. 10 billion is a number so large it ceases to be a number and becomes a concept, a vast empty space in the imagination. And our sun is a relatively average star. There are red dwarfs, small and cool, that will burn for trillions of years. Trillions. If the universe were compressed into a single year, the entire history of human civilization would occupy less than the final fraction of a second, while the red dwarfs would be burning steadily from the first days of January until the very end of December. And still, they end. This is the tragedy and the beauty of the cosmos. Nothing is exempt. The largest, most massive stars, the blue giants that burn with a furious, blinding intensity, exhaust their fuel in a few million years. They die in spectacular violence, exploding as supernovae, scattering their heavy elements across the galaxy, seeding the void with the building blocks of future worlds. The smaller stars die more quietly. They swell into red giants, engulfing their inner planets, then shed their outer layers into space, leaving behind a dense, glowing core, a white dwarf that will slowly, over billions of years, radiate its heat away into the dark, eventually becoming a cold, black cinder, a black dwarf, a dead star. This chapter moves without hurry through the enormous span between a star's first light and its last. It does not do this to impress you with the numbers, because numbers, as we have established, are useless when they get this big. It does this to let the numbers dissolve into something closer to a feeling, the feeling of deep time, the feeling of insignificance, not in a depressing way, but in a liberating way. When you truly internalize the lifespan of a star, your own problems, your own anxieties, your own desperate need for permanence begin to look very small. Imagine the birth of a star, a vast cloud of hydrogen gas, light years across, drifting in the cold dark of space. For millions of years nothing happens, it is just a cloud. Then perhaps a shock wave from a nearby supernova ripples through it, or perhaps the cloud simply grows massive enough that its own gravity begins to pull it inward. The collapse begins. It takes hundreds of thousands of years for the cloud to condense. As it shrinks, it heats up. The gravitational potential energy is converted into thermal energy. The core gets hotter, denser, more pressurized. Finally, when the temperature reaches 10 million degrees, the hydrogen nuclei are moving so fast that they overcome their electromagnetic repulsion and slam into each other. They fuse. Hydrogen becomes helium, and in that fusion a tiny amount of mass is converted into a vast amount of energy, according to the equation E = mc squared. The star ignites. The outward pressure of the radiation from the fusion perfectly balances the inward pull of gravity. The star enters the main sequence. It is stable. It will burn like this for billions of years. It is a perfect self-regulating engine, a sphere of plasma held together by its own weight, shining with a steady, reliable light. It is the ultimate expression of equilibrium. But the fuel is finite. The hydrogen in the core is slowly converted into helium. The helium ash accumulates. Eventually the core runs out of hydrogen. The fusion stops. The delicate balance is broken. Gravity wins, and the core begins to contract. As it contracts, it heats up even further until it is hot enough to fuse the helium into carbon. The outer layers of the star, heated by the new energy from the core, expand outward. The star swells. It becomes a red giant. It is no longer stable. It is pulsing, shedding its mass, dying in a slow, agonizing process that takes millions of years. Even the largest fires eventually run out of reasons to keep burning. When the star finally exhausts all its nuclear fuel, there is no more energy to push back against gravity. The star collapses. If it is massive enough, it collapses into a neutron star or a black hole, objects so dense that the laws of physics as we know them break down. If it is smaller, it becomes a white dwarf, supported only by the quantum mechanical pressure of electrons refusing to occupy the same space. And then the long wait begins. The white dwarf is hot, glowing with the residual heat of its collapse, but it has no internal energy source. It is just a hot rock in space. Over the next trillion years, it will radiate its heat away. It will cool. It will fade from white to yellow to red to a dull, invisible infrared. Eventually it will reach the temperature of the cosmic microwave background. It will be in equilibrium with the universe. It will be a black dwarf, dead, cold, gone. To sit with this timeline is to feel a profound shift in perspective. The light from a star that left it 1 billion years ago is just now reaching your eye. The star that emitted that light may already be dead. You're looking at a ghost. The universe is a graveyard of light, a vast dark space illuminated only by the delayed echoes of things that have already ended. The feeling this produces is not one of sorrow, but of a strange, quiet awe. We are here on a small rock, orbiting an average star in the middle of an ordinary galaxy, and we are able to comprehend, even if only vaguely, the scale of it all. We are the universe observing itself, trying to understand its own lifespan. The stars burn and they end. The light leaves and the dark returns. It is the oldest story in the universe, told over and over again in every corner of the cosmos. It is a story of immense energy and immense patience. It is a story that reminds us that everything, no matter how bright, no matter how hot, no matter how massive, is temporary. The fire burns, the fuel runs out, the ash cools. This is the way of things, and there is a deep, abiding peace in accepting it. We do not need to burn forever to be significant. We just need to burn while we can and let the light leave. The slowest possible fall. Here the pace changes. If the previous chapters were about the suddenness of breaking and the vastness of stellar lifespans, this chapter is about the agonizing, imperceptible slowness of descent. Everything in this chapter is falling, but so slowly that falling stops looking like an event and starts looking like a condition. It is not the sharp, sudden drop of an apple from a tree. It is not the rapid plunge of a stone into a well. It is the slow, creeping descent of a glacier. It is the gradual sinking of a tectonic plate into the mantle. It is the universe itself, sliding down the gradient of entropy, moving from a state of order to a state of disorder, at a pace that makes a glacier look like a sprint. A dropped stone hits the ground in a second. The physics of it are simple, elegant and fast. Gravity accelerates the stone at 9.8 meters per second squared. Air resistance pushes back. The stone reaches terminal velocity, or it hits the ground. The event is over before you can fully process it. The cause and effect are tightly bound, separated by a fraction of a second. This is the scale of human experience. We understand falling at this scale. We know the feeling of dropping a glass, the lurch in the stomach, the crash, the cleanup. It is a complete narrative in 2 seconds. But the universe's descent takes longer than language has numbers for. The heat death of the universe, the final state of maximum entropy, is a fall. It is the universe falling into a state of perfect, uniform, cold equilibrium. But this fall is not happening in seconds or years or even billions of years. It is happening in a timescale that requires scientific notation just to write down. The protons in the atoms of your body will decay in roughly 10 to the power of 34 years. The black holes will evaporate via Hawking radiation in 10 to the power of 100 years. The universe will reach its final, dark, cold state in 10 to the power of 1,000 years. Sit with that mismatch. It is the whole point. The human brain evolved to track the trajectory of a thrown spear, to judge the distance to a watering hole, to predict the changing of the seasons. It is a machine built for the short term, for the scale of the stone hitting the ground. It is entirely unequipped to comprehend the slowest possible fall. When we try to think about 10 to the power of 1,000 years, the brain simply gives up. The numbers become meaningless symbols. The concept of time dissolves. But the fall is happening. Right now. Everything is falling. The galaxies are moving apart. The energy is dissipating. The structures are dissolving. It is just happening so slowly that we cannot see it. We are like ants walking on the hull of a ship that is sinking in the middle of the ocean. The ship is going down, but to the ant the deck feels solid. The horizon looks stable. The world is permanent. The ant's entire existence will be lived on what it perceives as solid ground, completely unaware of the slow, inexorable descent into the depths. This mismatch between our perception and reality creates a profound cognitive dissonance. We feel the urgency of our own lives, the rapid ticking of our own biological clocks, the swift passage of our days, and yet we are embedded in a cosmos that is moving at a pace so glacial that it makes our entire lives look like a single frozen frame of film. We are trying to live in time of the stone while being subjected to the time of the universe. The slowest possible fall changes the nature of falling itself. When a fall takes a second, it is an event. It has a beginning, a middle, and an end. It is a disruption of the status quo. But when a fall takes 10 to the power of 1,000 years, it is not an event. It is the background. It is the condition of existence. The falling is not something that happens to the universe. It is what the universe is. The descent is the fundamental texture of reality. To perceive this, you have to change the way you look at the world. You have to stop looking for events and start looking for processes. You have to stop looking at the stone hitting the ground and start looking at the mountain wearing away. You have to stop looking at the star exploding and start looking at the star slowly dimming over trillions of years. You have to let your perception slow down to match the pace of the cosmos. It is a difficult exercise. It requires a kind of mental surrender. You have to let go of your need for things to happen quickly, for things to resolve, for the fall to end. You have to accept that the fall is the point, the descent is the journey. The universe is not falling toward a destination. The falling is the destination. The slow, creeping dissolution of all structure, all energy, all difference is the ultimate fate of everything. And yet, there is a strange beauty in it. The slowest possible fall is gentle. It does not crash. It does not shatter. It just gradually, quietly, imperceptibly lets go. It is the universe relaxing into its final state, shedding the tension of structure, releasing the energy of order, and settling into the deep, quiet peace of equilibrium. It is the ultimate rest. And if we can learn to see our own lives not as a frantic race against time, but as a brief, bright moment within the slowest possible fall, perhaps we can find a way to rest too. Perhaps we can stop trying to stop the fall and just enjoy the descent, a coin that refuses to land. Uncertainty gets a chapter to itself, uninvited but necessary. We like to think of the world as a deterministic machine. We like to believe that if we just knew all the initial conditions, if we just had enough computing power, we could predict the future with perfect accuracy. We like to think that the coin, once flipped, is already determined. The force of the thumb, the angle of the flip, the air resistance, the gravity, the height of the catch, it all determines whether the coin will land heads or tails. We just don't have the information to calculate it, so we call it a game of chance. But it's not chance. It's just ignorance. That is the classical view. That is the comfortable view. But at the smallest scales, the comfortable view breaks down. Nothing wants to happen at the smallest scales, and yet things happen anyway, quietly, without asking permission from probability. The quantum world is not a deterministic machine. It is a fuzzy probabilistic cloud. An electron does not have a precise position and a precise momentum. It has a wave function, a spread of probabilities. It is not here or there. It is a superposition of here and there until you look at it. And when you look at it, the wave function collapses and it picks a position. But why that position? There is no underlying mechanism. There is no hidden variable. It is truly, fundamentally random. A coin spun in the dark. In the classical world, the spinning coin is a blur, but it is still a solid object with a definite state. It is just moving too fast for us to see. In the quantum world, the spinning coin is literally both heads and tails at the same time. It is in a superposition of states. It is not until it lands, until it interacts with the environment, until it is measured by the table, that it decides what it is, and the decision is not determined by anything. It is a roll of the fundamental dice of the universe. This is the texture underneath everything else in the book, and it has been there the entire time without saying so. The glass of water, the shattered cup, the dying star, the slow fall, they are all built on this foundation of quantum uncertainty. The solid matter you are sitting on, the atoms in your body, the light from the stars. It is all just a manifestation of probability waves, a temporary stabilization of the underlying quantum fuzziness. We spend our lives trying to avoid uncertainty. We build walls, we make plans, we create routines, we seek certainty in religion, in science, in relationships. We want the coin to land. We want to know if it is heads or tails. The uncertainty makes us anxious. It makes us feel out of control. We want the world to be a machine, predictable and reliable. But the universe is not a machine. It is a game of chance, played at the most fundamental level. A door that might already be open. You're standing in front of a door in the dark. You don't know if it is open or closed. In the classical world, the door is either open or closed, and you're just ignorant of the fact. In the quantum world, until you reach out and touch it, the door is in a superposition of open and closed. It is both. The act of touching it, of interacting with it, forces it to choose. This is not just a parlor trick of subatomic particles. This is the nature of reality. The solid, deterministic world we experience is just a macroscopic illusion, a statistical average of trillions of quantum events. The certainty we feel is a trick of scale. If you could zoom in close enough, if you could see the fundamental texture of the world, you would see that nothing is certain. Everything is a probability. Everything is a maybe. And yet things happen anyway. The coin lands, the door opens, the star burns, the proton decays, the universe unfolds, not according to a strict predetermined script, but according to a roll of the dice. And the remarkable thing is that the dice roll consistently enough to create a stable, orderly universe. The probabilities are weighted. The laws of physics are the rules of the game. They don't tell you exactly what will happen, but they tell you what is likely to happen. And over the vast scales of time and space, the likely things happen so often that they become the inevitable things. The macroscopic world emerges from the microscopic chaos, as solid and reliable as a stone. But the stone is not really solid. It is just a very dense probability cloud. The certainty is an illusion. The uncertainty is the reality. To accept this is to accept a fundamental lack of control. It is to accept that at the bottom of everything there is a roll of the dice. It is to accept that the universe is not a clockwork mechanism, but a casino. There is a freedom in this. If the future is not strictly determined, then there is room for novelty. There is room for surprise. There is room for the unexpected. The universe is not just playing out a script that was written at the Big Bang. It is making it up as it goes along. The coin that refuses to land is not a source of anxiety. It is the source of all creativity, all change, all life. It is the reason the universe is interesting. If the coin always landed the same way, if the universe was perfectly deterministic, it would be a dead, boring place. The uncertainty is the spark. It is the texture underneath everything else. It is the quiet, invisible hum of possibility that gives the world its shape. Proton, one word, one idea, one impossibly long wait. Matter itself, The stuff of hands, of stone, of the chapter you just read, may not be permanent in the way it feels permanent. We look at a rock and we see something that will last forever. We look at our own hands and we see the solid, reliable building blocks of our existence. We trust matter. We trust its solidity, its weight, its persistence. It is the anchor in the chaotic sea of experience. It is the thing that remains when everything else changes. But the proton, the fundamental particle that makes up the nucleus of every atom, the thing that gives matter its mass and its identity, is not permanent. According to the most advanced theories of particle physics, the grand unified theories that attempt to bring all the fundamental forces together, the proton is unstable. It will eventually decay. It will break apart into lighter particles, a positron and a neutral pion, which will then quickly decay into photons. The proton, the bedrock of matter, is not a bedrock at all. It is just a very, very long-lived temporary state. The wait is impossibly long. The predicted half-life of a proton is greater than 10 to the power of 34 years. To put that in perspective, the universe is currently only about 1.38 times 10 to the power of 10 years old. The proton's lifespan is a trillion times longer than the current age of the universe. It is a number so large that it breaks the human mind. It is a weight that stretches far beyond the death of the stars, far beyond the evaporation of the black holes, far into the deep, dark future of the cosmos. But it will happen. Every single proton in the universe will eventually decay. The rock will dissolve. The hand will dissolve. The Earth, the Sun, the galaxies, all of it, will eventually dissolve into a sea of light. The matter that we trust, the matter that we build our lives upon, is just a brief, temporary eddy in the flow of energy. It is not permanent. It is just very, very slow to change. This is the densest room in the house, and you're asked to stay in it a while, because rushing through it defeats the purpose of having built it at all. The idea of proton decay is not just a dry fact of physics. It is a profound philosophical challenge. It strikes at the very core of our sense of reality. If the fundamental building blocks of matter are not permanent, then what is? If the rock will eventually dissolve, then what does it mean to say the rock is solid? If the hand will eventually dissolve, then what does it mean to say the hand is real? We are asked to sit in this room and confront the impermanence of matter. We are asked to look at our own hands, to feel the weight of our own bodies, and to understand that this solidity is an illusion. It is a trick of scale. The protons in our bodies are decaying, but they are decaying so slowly that we never see it happen. We live our entire lives in the brief, bright flash of the proton's stability. We mistake the brief flash for eternity. The room is dense because the idea is heavy. It is the weight of ultimate impermanence. It is the realization that nothing, not even the most fundamental, seemingly indestructible building blocks of reality, will last forever. Everything is temporary. Everything is passing. Everything is on its way to dissolving into light. To stay in this room is to accept this truth. It is to let go of the need for matter to be permanent. It is to realize that the value of a thing is not in its permanence, but in its temporary existence. The rock is beautiful not because it will last forever, but because it exists now, for a brief, fleeting moment in the vast, empty expanse of the universe. The hand is beautiful not because it will last forever, but because it can reach out and touch and feel and create for a brief, fleeting moment. The proton decays, the matter dissolves, the light spreads out into the dark. This is the ultimate fate of everything. It is a cold, dark, empty future. But it is also a future that is made possible by the temporary existence of matter. The protons hold together long enough to form atoms, to form molecules, to form stars, to form planets, to form life. They hold together long enough for the universe to create something beautiful, something complex, something that can look back and wonder at its own existence. And then they let go. They decay. They return to the light. The wait is impossibly long. But it is a wait that is worth taking. It is the wait for the ultimate truth of reality. It is the wait for the realization that everything is temporary, and that this impermanence is not a tragedy, but the very condition that makes existence possible. The proton decays, the room goes quiet, and in the quiet we understand. The last warm thing, after the density of the previous chapter, something softer, a shift in the texture of the air, a lowering of the voice, a dying ember, a voice trailing off mid-sentence. This chapter follows warmth to its final address. Not a place, exactly, but a threshold, past which there is only the memory of heat, evenly spread, going nowhere, wanting nothing. Warmth is a gradient. It is the difference between here and there, between hot and cold. It is the flow of energy from a place of high concentration to a place of low concentration. A fire is warm because it is hot, and the room is cold. The heat flows from the fire into the room, warming the air, warming the walls, warming your skin. The warmth you feel is the energy of the fire transferring itself to you. It is a physical connection, a sharing of energy. But the fire is finite. The fuel burns. The chemical bonds break, releasing energy as heat and light. The fire consumes itself, and as it consumes itself, it cools. The ember, once a bright glowing orange, fades to a dull red, then to a dark sullen cherry, then to a black ashen lump. The heat is still there, trapped in the mass of the carbon, but it is no longer concentrated. It is dissipating, radiating out into the room, warming the air by an imperceptible fraction of a degree. The last warm thing is the final concentration of heat in a cooling universe. It is the last ember, the last star, the last black hole, evaporating into a cloud of Hawking radiation. It is the final moment before the universe reaches thermal equilibrium, the state of maximum entropy, where the temperature is uniform everywhere and no more work can be done. A voice trailing off mid-sentence. The vocal cords vibrate, pushing the air, creating pressure waves. The sound travels across the room, vibrating the eardrum, translating the mechanical energy back into electrical signals in the brain. The voice is warm. It is full of energy, of intention, of meaning. But the breath runs out. The energy fades. The voice drops in volume. The pitch lowers. The words become slurred. And then silence. The sound waves dissipate, bouncing off the walls, losing energy to the friction of the air until they are indistinguishable from the background noise of the room. The warmth of the voice, the warmth of the ember, the warmth of the star, it is all the same. It is the concentrated energy of the universe, slowly, inevitably, spreading out. The second law of thermodynamics is not just a rule about cups and shattered glass. It is the rule about warmth. Heat always flows from hot to cold. The gradient always levels out. The warm thing always cools. After the density of the previous chapter, something softer. A shift in the texture of the air. A lowering of the voice. A dying ember. a voice trailing off mid-sentence. This chapter follows warmth to its final address. Not a place exactly, but a threshold, past which there is only the memory of heat, evenly spread, going nowhere, wanting nothing. Warmth is a gradient. It is the difference between here and there, between hot and cold. It is the flow of energy from a place of high concentration to a place of low concentration. A fire is warm because it is hot, and the room is cold. The heat flows from the fire into the room, warming the air, warming the walls, warming your skin. The warmth you feel is the energy of the fire transferring itself to you. It is a physical connection, a sharing of energy. But the fire is finite. The fuel burns. The chemical bonds break, releasing energy as heat and light. The fire consumes itself, and as it consumes itself, it cools. The ember, once a bright glowing orange, fades to a dull red, then to a dark sullen cherry, then to a black ashen lump. The heat is still there, trapped in the mass of the carbon, but it is no longer concentrated. It is dissipating, radiating out into the room, warming the air by an imperceptible fraction of a degree. The last warm thing is the final concentration of heat in a cooling universe. It is the last ember, the last star, the last black hole evaporating into a cloud of hawking radiation. It is the final moment before the universe reaches thermal equilibrium, the state of maximum entropy, where the temperature is uniform everywhere and no more work can be done. A voice trailing off mid-sentence. The vocal cords vibrate, pushing the air, creating pressure waves. The sound travels across the room, vibrating the eardrum, translating the mechanical energy back into electrical signals in the brain. The voice is warm. It is full of energy, of intention, of meaning. But the breath runs out. The energy fades. The voice drops in volume. The pitch lowers. The words become slurred, and then silence. The sound waves dissipate, bouncing off the walls, losing energy to the friction of the air until they are indistinguishable from the background noise of the room. The warmth of the voice, the warmth of the ember, the warmth of the star, it is all the same. It is the concentrated energy of the universe, slowly, inevitably spreading out. The second law of thermodynamics is not just a rule about cups and shattered glass. It is the rule about warmth. Heat always flows from hot to cold. The gradient always levels out. The warm thing always cools. This chapter follows that cooling. It sits with the ember as it fades. It listens to the voice as it trails off. It feels the warmth as it dissipates. It is a chapter about letting go, about accepting that the warmth cannot be held, that the fire must burn out, that the voice must fall silent, quiet. No new information arrives here. The book has said what it had to say. The glass of water has been observed, the cup has been shattered, the stars have burned out, the slow fall has been witnessed, the coin has refused to land, the proton has decayed, the last warm thing has faded. There is nothing left to add. The universe has reached its final state, and the book has reached its final page. Only the return of a coldness first felt in Chapter 1, except now it means something different. Or perhaps it always meant this, and you simply hadn't caught up to it yet. In the first chapter, the coldness was the physical reality of the room. It was the temperature of the air, the chill of the glass, the winter breath dispersing in the air. It was a sensory detail, a setting for the observation of the almost nothing. But now, the coldness is different. It is the coldness of the final universe, It is the coldness of thermal equilibrium. It is the coldness of the end of all things. It is not just the temperature of the room, it is the temperature of reality. It is the deep, profound cold of a universe that has run out of energy, out of gradients, out of time. And yet, it is not a frightening cold. It is a quiet cold. It is the cold of a room after everyone has left. It is the cold of a fire that has burned down to ash. It is the cold of a long day that has finally ended. It is a cold that brings relief, not pain. It is the cold of rest. The book does not resolve. There is no grand conclusion, no final answer, no tying up of loose ends. The universe does not resolve. It just ends. It reaches a state where nothing more can happen. The story is over, not because the plot has been resolved, but because there are no more events to drive the plot forward. It stops, the way rooms go quiet after everyone has said what they came to say. The conversation has run its course, the words have been spoken. The silence that follows is not an empty silence, it is a full silence. It is the silence of completion. It is the silence of a job well done, of a story fully told, of a life fully lived. The quiet is the final texture of the book. It is the space between the words. It is the white space on the page. It is the pause at the end of a sentence. It is the breath you take before you close the cover. In this quiet, the reader is left alone with the thoughts the book has provoked. The glass of water, the shattered cup, the dying star, the slow fall, the spinning coin, the decaying proton, the fading ember. They are all still there, echoing in the mind. But they are no longer the focus. The focus is the quiet. The focus is the space they leave behind. The quiet is the ultimate reality. It is the background against which all events occur. It is the silence from which all sound emerges and to which all sound returns. It is the dark from which all light emerges and to which all light returns. It is the cold from which all warmth emerges and to which all warmth returns. To sit in the quiet is to sit in the fundamental nature of the universe. It is to accept that the noise, the light, the warmth, the events, the drama, they are all temporary. They are brief interruptions in the long, quiet, dark, cold eternity of the universe. And when the interruptions are over, when the glass is empty, when the cup is shattered, when the stars are dead, when the fall is complete, when the coin has landed, when the proton has decayed, when the last warm thing has faded, the quiet returns. The quiet is not nothing. It is the everything. It is the canvas on which the painting of the universe is drawn. It is the silence in which the music of the spheres is played. It is the dark in which the light shines. The book stops. The words end. The page is blank. The room is quiet. The cold is deep. The universe is at rest. And in the quiet, in the cold, in the dark, there is a profound, abiding peace. The weight of almost nothing has been lifted. The fall is complete. The coin has landed. The fire is out. The voice is silent. The proton has decayed. The warmth is gone, and there is only the quiet of the room, the quiet of the page, the quiet of the mind, the quiet of the universe. It is enough. It is all there is. It is all there ever was. The book is closed. The light is turned off. The door is shut. Quiet.